Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. Now let's look at electrochemistry, and so it will say to us now the relationship between the concentration of an electrolyte and a cell potential is investigated using the electrochemical cell represented by the cell notation. Now remember, before a salt bridge, we have anode. After the salt bridge, this is the cathode. And remember the analogy, an ox, red cat. What does the analogy mean? The analogy said anode oxidation occurs, cathode reduction occurs. Okay, this is our salt bridge. Okay, yes. Then this is our phase border or phase change. Yeah. All right. Now let's see. The concentration of M2 plus is changed and the corresponding EMF is measured. The concentration of aluminium ions and the temperature at standard temperature. So standard condition. What is standard condition? Concentration of, let me say, concentration of 1 mole per decimeter cubed, temperature of pressure, atmospheric pressure of 1.1.3 kilopascals, and temperature of 25 degrees Celsius temperature. Okay. Now we are here it is again. So we see an increase in the concentration of M2 plus causes an increase in what? In the EMF produced. Okay. So I want to believe somehow it means our reaction it is like this. Let me see. If this is aluminium and it undergoes oxidation, so it's gonna be aluminium that undergoes reduction. Oxidation is gain. Reduction is loss. Okay, oxidation is gain. Yeah, I'll see it when I answer questions. So now identify the reducing agent in this cell. Now the reducing agent is what? Is the one that gets finished up again. But I want you to see something. Can you see that the EMF increases when they still add this one? They what happens? If this one increases, it does not decrease in anyhow, or it does not do this shape that it goes, and now does this, do this maybe after some certain time. Okay, so can you see now it does not do that? So it means now aluminium, it is our what in this case? Our aluminium, it is our limiting reagent, and now aluminium, not Al. So not Al plus. Okay. Yes. Now I'll show you why I'm saying it is aluminium with a equation. Okay. Now determine the concentration of M2 plus that will produce an EMF of 1.87. So the division here, when I was counting, it was 1. Here there were 10 divisions. So from this to this, the division it is 0.025. One division. Okay. So now let's count. 1. Let me try to zoom this out. Let me try to minimize my pen also. The first one here, it is 1.81, 1.82, 1.83, 1.84, 1.85, 1.86, 1.87. I go to 1.87. Okay, then I go directly down. Okay, now I want to read off what is this value. Remember I said the division is 0.025. So 0.25 plus 0.025, it is 0.275. Then here it is 0.3. Then here it is 0.325. So you'll add here, you can take your calculator and say 0.25 plus this one for the first one, the answer that you got plus this one, then you'll get that one, the answer plus this one, you'll get 0.325. Okay, so The answer here, the answer here it is 0.325. Let me minimize that. It is 0.325 mole per decimeter cubed. Let me just use mole per decimeter cubed. Now, how will the concentration of M2 plus be affected as the cell operates? As the cell operates now, remember it undergoes reduction. So reduction. So M2 plus 2 electrons, it will form M. So as time goes on, the forward reaction is favored. So the concentration of this one will decrease. Again, the concentration of this one will decrease, and now what will happen there? The concentration of that one will decrease. Okay, when we give an answer, you're gonna say M2 plus is reduced. It undergoes reduction. Okay. Why? Because its oxidation number was 2 plus to what? To 0. That's how you can also check it. Okay, if you undergo reduction, it means your oxidation number decreases from 2 plus 2 to 0. If you undergo oxidation, it means your oxidation number increases from whatever to whatever. Like here, let me prove this. I said this one undergoes oxidation. It is an anode. Okay? So can you see the oxidation number moved from 0 to 3 plus? So it was an increase. So cathode, it is a reduction. It moves from 2 plus to 0. It is a decrease. I want to believe you are following. Okay. It is reduced or used up. Okay. Those are the correct lines you can use. Okay. Or it is an oxidizing agent. Sorry. Okay, now they ask us potassium nitrate is used as a salt bridge on this equation. To which electrode will the K plus go to? Now, I want you to get it like this. The Cat plus, we call them what? Cat plus, we call them cathode. Cat ions, sorry. Then the NO3 minus, even though it is a spectator ion, we call them the anion. Ion. So I want you to know this. Cation will go to the cathode. Can you see cat? Anion will go to the anode. Let's see. Now, K plus, it is a cation. It goes to the cathode. Where is the cathode? Here is the cathode. So it will go to the M. M. Okay? It will go to M. Okay, you see they asked aluminum or M, so it will go to M. Can you see the analogy here helps me a lot? It should help you a lot also. Identify metal M with the use of a calculation. Now, remember how do we find that one? You can say E naught of the cell, it is equal to E naught of reduction minus E naught of oxidation. You can also use other words like E naught of the cathode minus E naught of the anode. Okay, do not say E naught of the reduction. Okay, minus E naught of the oxidation, it is 0. You will get 0. Then now let's calculate E naught of the cell. Which one might ask, which one is exactly E naught of the cell, because now we have many values here. Remember, we should check at the standard. The standard condition says to us the concentration should be at 1 mole per decimeter cubed. I stated that, right? I stated that. So now, when our concentration is 1 mole, let's check what is our volume. Let me try to resume that and do this together. So here is our 1 mole here. Okay. Can you see? So our voltage, it is E naught of the cell, it is 2 volts. You had to read this from the graph. Then we have E naught of the cathode. Why are we saying this is the cathode? Because M, we are trying to figure M, and M, remember, undergoes reduction, and it is a cathode. So we'll just give it an unknown, minus E naught of the oxidation. What is the oxidation number of aluminium? Oxidation number of aluminium. And you should check aluminium that has 3 plus and Al only. So it is something like negative 1.66, okay? I believe you see that. Minus of the formula, minus 1.66. Then now you do your math. You do your math, you get something like 0.34. And now you have to identify which one is an oxidation number, sorry, the English is gone. That has a reduction potential of 0.34. So you'll know there, I took short half thing here. So you'll realize that M is copper. M is copper. Okay, copper. And this copper, it is a copper that one, yeah, 2 plus. Okay, yes. So now let's answer other questions. M is now replaced with magnesium. Which electrode, a aluminium or magnesium, will be anode? Now we cannot be sure. We cannot say aluminium was anode, therefore this one will be cathode. No, we have to double check. Okay, I use table 4b. Table 4b. And now, how do I do this? I say I will use a C method. The one that goes there and the one that goes there. I'll check. What do I mean by that? I'm saying I'll locate my aluminium. Okay, here's my magnesium. Here's my aluminium. I'm saying I'll apply my C method. How does my C method apply? It says now like this between the two that I want. So it means this one will go in that direction and this one will go in that direction. Meaning for this one, the reaction for this one, it will be Mg going to Mg2 plus 2 electron. Can you see I'm writing it like that, but in a formal way, okay? Then this one will move from here to there. So meaning this one will be aluminium 3 plus 3 electrons, giving us what? Aluminium. Now let's answer the question. Which one undergoes oxidation? Anode, it is the oxidation, right? Remember, oxidation, it is an increase in oxidation number. Or you can say it is a loss of electron. Again, so can you see now this one undergoes oxidation? Why? Because there is an increase in oxidation number. This one undergoes now what? Reduction. Okay. We'll answer that why we say now it is that. So we say it is magnesium. Refer to the strength of the oxidation agent to explain your answer. Now, a Mg aluminium. Okay, I think like I took a short. I took a short. I was supposed to take, okay, a full extended thing here. This table I was supposed to take where it shows which one goes where, like the relative strength. Okay, but I'll tell you. So we are comparing between what? We are comparing between magnesium and aluminium. Again, we are comparing between aluminium and magnesium. Now, it goes like this. This table here on the side, we had something like uh, in here. Okay, let me remove this. Going down there, we had an increase in the oxidation ability. Oxidation ability. Okay, from here going down, and then from here going up. From here going up, we had an increase in reduction ability. Reduction ability or agent. Okay, so this is what we had. Now we have to compare. Now remember, the one with the strong oxidation ability is the one that will be reduced. Okay, is the one that will be reduced and it will oxidize others. Okay, so if this is a strong oxidation ability, it means between Mg2 plus and aluminium, which one is a strong oxidation oxidizing agent? So can you see if the strength increases as you go down? So it means this one, aluminium 3 plus, has a what? Let's answer that here. Aluminium 3 plus has a what? Has, or is a stronger oxidizing agent. Remember, oxidizing agent undergoes reduction. Al3 plus is a stronger oxidizing agent. Okay, therefore, or than what you have to say, than, sorry, you have to say than Mg2 plus. Okay, therefore, Mg, this one, Mg will be reduced, because if this one is a stronger oxidizing agent, it makes others to undergo a oxidation. Okay, this one has a stronger oxidizing ability, so it causes the other one to undergo what? Oxidation. Okay, so if uh, this one has a stronger, so this one has a stronger reducing agent, so it will cause this one to undergo reduction. Okay, reducing ability goes as we go up. Then now what will happen? I'm saying therefore Mg will be oxidized. Okay, will be oxidized to what? To Mg2 plus, but that is not important. What's important is that it will be oxidized. Okay. Kappa, you can say now Mg2 plus. Mg2 plus is a weaker oxidizing agent than aluminium 3 plus. Therefore, Mg will be oxidized because it is a weaker. So I want to believe you are following and followed me closely. So yeah, that's all for this one. Let's meet again on the next question 9, the last one now. Okay, yes, electrolytic cell.